So I'm Vivek Singhal, co-founder and data scientist at SalesTrack, and we are an AI startup based in India. Okay, let me just continue. This session is being recorded. So just a plug on our startup SalesTrack. We are a leading AI startup in India, and we focus on artificial intelligence and deep learning, machine learning. We are working on multiple machine learning innovations and solutions for selected verticals. Our research and content is quite extensive. We are a research-oriented company, and we have a community of data scientists with whom we work. So what are our focus areas? We are interested in artificial intelligence solutions in space of e-publishing, marketing automation, text recognition, computer vision, etc. We are working on algorithmic design in areas like probability modeling, regression classification, supervised and supervised learning, as well as deep learning with neural networks. We use Python, TensorFlow stack for development, and we are also working on Amazon Alexa chatbot there. We produce a lot of research content, machine learning. You can find some of that on our blog, on our website, and community, and a talk series. This webinar is part of our Disrupt 4.0 talk series to evangelize AI and help the community with artificial intelligence research and innovation. Of AI first. What's so hot about AI? Why is it breaking out now? And what kind of applications do we see being enabled with AI? Okay. Mr. Andrew Nag, or Professor Andrew NG, is a very famous data scientist from Silicon Valley. He is a professor at Stanford University, Department of Computer Science. Until recently, he was the chief data scientist at Baidu, the Chinese search engine company. He has said that AI is the new electricity. So the impact electricity had on the human society, we expect AI and machine learning will have similar level of impact. Okay, so it is very, very impactful. So where we were and where we are going. So we started with the Industrial Revolution 1.0, 2.0, 3.0, and now we have Industrial Revolution 4.0. So in the last Industrial Revolution 3.0, we had electronics, automation, the internet, and so on. But now we see connectivity and we see artificial intelligence. We see IoT, we see blockchain. So lots of interesting deep tech stuff happening now, and AI is at the forefront of it all. It is enabling amazing, machine intelligence. Why is AI happening now? What happened now? So what happened now was big data. So the other thing which happened now is intensive computing hardware, which became very cheap. So talking about big data, you see, data is the new oil, as many folks have said, and there's battle for ownership of data as well as deriving benefits and insights from it. So you can see it is going to 180 zettabytes as per IDC research company by 2025, and there's massive amounts of unstructured data flowing from social media, from transportation, and all kinds of sensors, biological sensors, IoT sensors, and so on. And earlier, data was used by firms like Facebook and Google for targeted or personalized advertising, but now it is powering, n number of AI services or cognitive services, as we call them, some of which are developing into business models or revenue models. So the thing about data is it has a network effect. So the companies which are data rich can use data to attract more users. These users generate even more data once they use these services, and this additional number of users, additional data helps these companies to produce even more high quality services, and which allows them to attract even more users. So there's a network effect which goes with data, and hence the reason companies like Google, Facebook, Amazon are becoming much too powerful, and some commentators are worried about their undue power because of the amount of data they are collecting about the world. So the chart there shows how data is now proliferating and so AI feeds off data, and that is the reason why AI is gaining foothold now, because there's a lot of data to train AI now. Earlier we didn't have this much data or structured data to train AI, and we also have cheap hardware from the likes of NVIDIA, who are providing us highly intensive computing chips like GPUs or graphic processing units. So between big data and intensive computing power, we see the rise of artificial intelligence. Okay. So just to get the definition out of the way, what is AI after all? It is a branch of computer science that creates intelligent machines that work and react like humans. So it's basically making machines intelligent, or make them simulate human intelligence. So AI-based machines can use big data, and that businesses are collecting to identify patterns. So we can identify interesting insights or pattern about how humans are interacting with applications, and develop more and more rich analytical applications. Some examples are listed there. We hear a lot about autonomous or self-driving cars, and also we hear about AI systems beating the world chess champion or the world Go champion. Go is a game played in Oriental countries, Korea and China. And chess is a popular global game. And we have AI systems which have beaten the reigning world champions in these games. And we also have AI which is understanding human speech now. For example, the Amazon Echo chatbot, which is able to interact with humans in a household and render different kind of services. Okay, let's just keep going. So one interesting example of AI, in banking. So there's an Indian bank called HDFC, which has deployed these robotic assistants in some of its branches, and they call it IRA, or Intelligent Robotic Assistant. And you can walk into the branch, and it's a banking concierge robot, and it is able to answer your questions and also do, user identification or authentication by computer vision. So these kind of robots we are beginning to see in businesses, and in some cases in some households as well. So what are the top 10 use cases of AI, where the maximum money is for AI businesses? So if you are running an AI business or wanting to get into it, then you'll find these are the areas where the maximum spend who is going to be, as per this research. So machine vehicular object detection, computer vision, autonomous cars. So that is the top area where money will be spent for AI. Then we see image recognition, classification, tagging, as in image processing on Facebook and so on. Then healthcare data processing in hospitals and labs, and then algorithmic trading on Wall Street and other stock markets, and localization mapping, predicting maintenance, predicting failure. So these are some of the top use cases where we see the AI spend going forward over the next 10 years. So what are some major types of artificial intelligence we see being adopted? One prime example many of us are exposed to is chatbots through that Amazon Echo device or Apple Siri perhaps, and it uses something called natural language processing, or NLP technology, which is able to understand human speech, and it can do speech to text, text to speech, and so on. Then we also see AI in learning and adaptive systems, for example in educational environments for tailoring education for students levels, and then problem solving in different areas. We see AI in visual computing, for example image processing, face detection, or those kind of applications. Then we see robotics, and gaming is a heavy user of AI, and modeling in manufacturing or supply chain. So AI has very, very wide use, and I don't think there is any industry which will not be impacted with AI going forward. So one of the most popular applications of AI is natural language processing, or NLP. Now there are various kinds of NLP. So one is natural language processing, the base technology. Is also natural language understanding, which is able to understand text and speech. For example, for things like profanity filtering, sentiment detection, classifying text into categories or topics, detecting key entities or metadata within text. Some examples are Alexa, Siri, and Google Assistant, and these are coming into our households now. And also natural language generation, so it is able to convert text to speech, or it is able to convert structured data into text. So these are some variations of natural language processing technology. Hilton is using this robot called Connie from IBM Watson. IBM Watson is the AI platform from IBM. IBM is one of the biggest players in artificial intelligence, and they have this platform called Watson, which supports broad array of AI services and applications. So Hilton hotel chain, and in some hotels in the US, they've employed this robot from IBM Watson, which is Watson enabled essentially, and it's a concierge robot. So you walk into a hotel reception, it can guide you to your room or answer other services around hospitality. There's a YouTube video link, you can check it out on YouTube. Some other areas we see similar robots: hospitality, robotic process automation, which is used in call centers, transportation, security, military, and so on. So we see AI coming up in gaming. As way back in 1997, IBM supercomputer Deep Blue had beaten the chess grandmaster Garry Kasparov from Russia at that time. And Garry Kasparov wrote a very emotional novel about the concept of AI after that. So you can check it out on Amazon. A very interesting book by Kasparov on AI. And recently we find that Google Brain team or their AI team has developed this program called AlphaGo, which beat the world Go champion, KG of China, and Lee Sedol of Korea. So this Go game has nearly infinite moves. It's very hard for humans to master this game, but AI was able to beat the world champion in this game. So we have been talking about lots of AI apps. Now, if I am going to introduce AI in my organization, so what are the things I need to take care, because AI requires a certain business process methodology, and a certain philosophy or thinking how we do things. So first of all, we need proper data. It can't work with incomplete knowledge. So we need to understand our business and map it how AI will fit with that. And then, of course, AI is very use case centric. So one size does not fit all. Okay, so we have to look at the use case and develop custom AI or machine learning applications around that use case. It needs, proper customer data. So we can't work on incomplete data because AI needs to train on, lots of data. So data is what feeds AI. That's how AI gets trained, and we need sufficient training of AI systems. So you can't have it partially trained, or you have to retrain it again and again to make it more and more intelligent, more and more accurate. And then we have to define what are our performance metrics. So how do we define the success of our AI program? So those things have to be taken care if you are going to get into AI or already working on AI. So this slide has some interesting applications just listed out. So we have talked about image processing, optical character recognition, autonomous cars, which also need, computer vision to identify the scene in front of them. We have text analysis for detecting spam, whether an email spam or good email, detecting social media sentiment. How is Mr. Donald Trump doing? We can do Twitter analysis for that, and extracting information insight, and data mining. We can do anomaly detection, for example, in credit card transactions, if there's some malicious transactions, and healthcare for diagnosing patient data, as well as for image scans like CAT scans or X-ray scans using computer vision tech. We can also do cancer or oncology detection. It's used in drug trials by pharma companies. It is being deployed for video games, for teaching video games using something called reinforcement learning, which is a branch of machine learning. And then, it is, of course, robotics is completely AI. It is being used for industries as well as human simulations. So this slide just shows the intense need for AI talent and the shortage of it. So you can see the employers have these many positions open in AI, but the supply of AI talent is highly limited. Why is this? So the learning curve for AI and machine learning is very steep. It is one of the most difficult computer science subjects we have seen on the application side so far. and it is much more difficult than web development or mobile app development because there's mathematical algorithms involved. So we have to get back to our maths and linear algebra and understand the algorithms and then use these platform programming stacks to actually deploy that. There's a steep learning curve in ramping up on AI and machine learning. That is why there's a big skills gap. And so I think all of us will do very well if we can get into this area or already in this area. The salaries in AI are pretty high right now. Okay, let's look at some basics of AI and ML technology. So far we discussed some of the applications and different concepts around overall AI. And now we'll be looking at some basics of artificial intelligence and machine learning. So what is AI? AI is basically simulating human intelligence, as we said before. And what is machine learning? Machine learning is a branch of AI. Here what we do, we feed data and we train machines to learn from this data. So these machines are trying to derive an algorithm after observing the data from the environment. So this process of teaching machines from data is called machine learning, and it is basically a branch of AI. Machine learning is what enables AI to happen. So again, a list of applications listed there. The list of applications is quite endless, frankly, and we can go on and on with this list. So as we said, machine learning is a branch of AI, and in here we are trying to build algorithms that allow computers to learn to perform tasks as opposed to explicitly program. So before we would have to program these rules in classic analytic software or software engineering discipline, but now the program is learning by observing the data, and it is deriving insights by observing the data. And so we talked about AlphaGo, the Google program defeating the world champion in this space. Again, there's a YouTube video, you can check it out. Machine learning. So, how is it different from traditional analytics? So before traditional analytics in IBM, SPSS, SAS, or other kind of analytics software, we would have to hard code the rules. The developer or the technical architect would have to hard code the rules in the program. Whereas machine learning learns the rules from looking at data. So that's sort of a fine difference between the two. Now, machine learning can learn from labeled data, supervised learning. So labeled data means I have an input X and output Y. So for example, I have 1,000 patients and patient data, and I also know which of these 1,000 patients have developed diabetes. Let's say 100 of the 1,000 patients have developed diabetes, for 10%. So I have input X, which is the 1,000 patients data. I have the output Y, which is the 100 patients who develop diabetes. That is the Y. So using this XY combination, I'm able to train a model which can predict diabetes for future patients. And unlabeled data is unsupervised learning, where I'm provided input X but no output Y. So for example, I just give you 1,000 patients data and I ask you to randomly determine who's a healthy person, who's not, out of the blue. So there's no corresponding output label Y provided. This is called unsupervised learning. It's a much harder problem to solve, but we can still do a couple of things with that, which we'll see a bit later. So computers can take decisions that appear subjective. For example, an ML algorithm called logistic regression can determine when to recommend cesarean delivery. For those of you who have had babies, can relate to this fact, whether to do a normal delivery for a mother or a cesarean delivery. So ML algorithm can optimally predict what is the correct procedure to a doctor. Another algorithm, naive Bayes, can detect valid emails from spam. Okay. So some of the key features of machine learning, it is very computing intensive, and hence the need for those highly intensive computing chips from GPUs, IBM, and so on. It is very computing intensive. It may involve repeated retraining to improve on the learning. So we have to train the model again and again so it can improve on its accuracy and predictions. It needs a lot of training data, so we are able to get big data now, and hence this need has been fulfilled now. As data gets added, ML training can be automated, and it can progressively learn from new data which comes into the system. This is called incremental learning or stochastic learning. Okay. And for example, new spam words are coming in on new kinds of speech. So we can apply incremental learning to learn from new data which is coming into the system. So we have been talking about AI, deep learning, machine learning. What are the differences really? So this diagram shows the overall, universe is called AI here in this segment, and within that we have a machine learning, which basically we use data to train, machines to learn from data, and thus enable AI. So it's a branch of AI in that sense. Then we have something called representation learning, which is trying to learn the hidden form of the data, and then within that we have deep learning. So deep learning is the latest and greatest, most advanced machine learning which is available today, and it is enabled via artificial neural networks, which are modeled on the human brain pattern. So deep learning is what is now enabling applications like image recognition, speech recognition, text analytics, and so on, driverless cars, and so on. So up till now, these problems were hard to solve with core machine learning, but with deep learning neural networks, we are able to tackle some of these more complex problems now. Okay. So just to clearly understand the difference between traditional business analytics or data analytics and machine learning. So earlier you would be given a problem, and you as a developer or technical architect would have to hard code the rules in the program, and then you will send the program for testing. If it passes the testing step, you would put it in production. If it fails the testing step, then you will send it for review and resolutioning back to the design or architecture team. So this is the way software lifecycle works typically so far. Now let's look at in the machine learning world what is the difference. So the only difference in that diagram is the way we train the model. We don't hard code the rules anymore. We feed the training data, which is the input X, output Y, and we have a lot of those data samples available. Hopefully, we feed that data into the model, and the model learns the algorithm Y is equal to Fx from that data. So essentially, the model is trying to reverse engineer the algorithm Y is equal to some function of X by observing current data. And once it has that learned algorithm Y is equal to Fx, we send it for the testing step. If it passes the test, we put it in production for predicting future output Y for any new input X. If it fails the test step, we review for errors and we go back to resolutioning the algorithm. Okay, so this is the sort of fine difference from traditional programming or traditional analytics and the modern machine learning world. Now, let's look at machine learning and its uses. Let me just see if there are any questions so far. Yes, so just a note here, we'll take questions in the end so that we can maintain the flow. Okay. All right, so let's get back to machine learning and its uses. Machine learning is related to data science. Data science was the classical study of data and deriving insights and patterns from data. So that was data science. It was a broad category of data engineering or data analytics. Now machine learning is related to it because it uses a lot of the same algorithms. But in this case, we just learn the algorithm by observing the data, or the machine learns the algorithm by observing the data. So that is sort of the fine difference, but it's pretty related to data science. So that's why we also call AI or machine learning scientists and data scientists. So essentially, we are doing the same thing, but in this case, there's a slight difference where we are using data to train the algorithms. Okay, and now machine learning facilitates AI. So in that sense, machine learning is what connects AI with data science. So what are the broad classes or uses of machine learning? So you can see the list here: classifying stuff, developing trend or pattern analysis, checking anomalies, checking how data clusters are organized, and deciding a future course of action. So let's look at all of them one by one. So classification first. So in classification, what we are trying to answer is what class, okay? So what category or what class of something. So that's the fundamental question we want to answer. So for example, if there's an email, is it spam or good email? So what class of email is that? Is it spam or good email? If you apply for a bank loan, should you get a bank loan or not? Yes or no? No. Yea or nay? Is this email spam or ham? Ham is good email. Will the kid pass the exam or not? So this is classification. We are trying to train a model which can detect the classes, all right? And we also can have multi-class classification. So we can have more than two classes. For example, a bank customer is high, medium, or low risk for giving credit or bank loans. Is this article about politics, sports, culture, or entertainment? So I could have n number of classes. So we call it multi-class classification. Which category this product belongs to? Is this a car, or is this a truck, or is it a cycle, and so on? Okay. The second class of machine learning algorithms deals with trend analysis or regression. So for example, I'm given these blue dots. Each of them is an x comma y combination, right? From our linear algebra days, each blue dot can be represented by a value of x and a value of y. Now I am trying to find the equation of that red line which satisfies the blue dots to the maximum extent. So that is trend analysis or line fitment. As you can see, this algorithm, the red line, which is my trained algorithm, does not pass through all the blue dots precisely, but it is approximately satisfy them. So we say machine learning is an approximate science. Okay, so we can say, okay, we can predict the value of y given an x with 80 or 90% accuracy, because the line is an approximate line. I cannot create a line which passes through every blue dot. It would be a zigzag line and not a practical algorithm I can use for my purpose. So we create an approximate line which satisfies the blue dots to the greatest extent. Okay. Uh, now, an example would be, what would be the price of houses in New York? So for example, trying to create a trend analysis for house prices, or what is going to be the population of the world. So we can basically predict how much of something, okay, and how much will it rain, in the next rainy season, or what is the performance rating. So we are trying to predict what is how much of something instead of what class. The difference between classification and regression is that was what class, this is how much. So that is the simple difference. Now another class of algorithms detects anomalies. So for example, detecting suspicious credit card transactions or finding criminals from a set of population, right? So we are trying to find characteristics which are able to tell me if this banking transaction is fraudulent or suspicious or malicious in nature. We're trying to find criminals from a set of people. So this is called anomaly detection. Then one more segment of algorithms has to do with classifying or clustering data. So for example, I'm trying to cluster gold fruit from citrus fruits. So I'm trying to develop from given a set of fruits, I'm trying to find which ones are in gold fruit segment, which are in citrus fruit segment. So this is called clustering, and we are trying to discover clusters. And it's a method for grouping similar kind of objects. This is classically unsupervised learning because we are not given ground truth labels from before. We are just given a set of fruits, for example, and we have to just classify them out of the blue. So we have some algorithms which can achieve this. Okay. And for another example would be, we can identify customer segments like urban, semi-urban, rural. When we let's say we have a retail business, we want to segment our customers so that we can tailor our offerings based on different segments. So finally, we have one more class of algorithms. It's called reinforcement learning. Now in here, the way we teach the model or the agent is by giving it rewards. So the agent or the model or the robot, it does some action A, and the environment rewards it with reward R, and then the agent moves from state ST to ST plus 1. So basically, I am rewarding the agent with certain reward. In some cases, we can also attribute a penalty if the action is not desirable. So if the action is desirable, then we give it a reward. If the action is undesirable, we might choose to penalize it. So by this system of rewards, the agent learns what is the right behavior. This is called reinforcement learning or reward-based learning. It is classically used in self-driving cars and also video games. So in self-driving cars, in simulated environment, when it does not hit people, we give it a reward. And in a game, when it does the desirable behavior, the agent, then we give it a reward. It's the same way we do in robotics. So we give a reward to the robot in the software program if it does what we expect it to do. So by giving it rewards, we can train an agent to do the right actions. Okay, this is called reinforcement learning. Finally, we are in the phase of deep learning now. So nowadays we hear a lot about deep learning neural networks. So this is a relatively new phenomena. It has, I mean, this technology was there in university research for last 70, 80 years. But recently some professors like Professor Geoffrey Hinton, from University of Toronto, and few others have done some interesting innovation which has made this possible. So neural networks have been there for a while, but now they are breaking out and they are able to solve much more complex, problems. For example, image detection. So this the infographic shows how we can develop a neural network to detect the object in the image, whether it's a car or a person or an animal. Okay. So in this image, each pixel represents a feature. So what is an image? It's a set of pixels, right? As we know from our graphics word, and each pixel has RGB value, red, green, or blue, value, which classifies its color. So these pixels form what we call input features and the input neurons, as they are called. So all those circles are called neurons, and they are basically simulating the human brain neuron. So neural networks are based on the concept of neurons in human brain, which divide and conquer. So you can see a lot of neurons are working here together in layers to solve this problem. So I feed those pixels for the features into the first hidden layer, and the first hidden layer is able to detect edges on that image. The second hidden layer is able to detect corners and contours in that image, and the third hidden layer detects object parts. For example, if it is a car, then car tire or car windshield, or if it's a human, then human face, ear, nose, and so on. And the final layer it spits out the output, whether it's a car, person, or animal. So this is a divide and conquer mechanism. These neural layers work in conjunction to slowly solve this problem step by step. So this is what is called an artificial neural network. It is modeled on the concept of neurons in the human brain. So there are millions of neurons in the human brain which work together to solve these complex human decision points. This is how a neural network also works as well. Okay, so just to summarize there, we are looking at training an algorithm and trying to reverse engineer an algorithm based on observing lots of input and output data, x comma y, and we are trying to reverse engineer the algorithm y equal to some function of x. Then we put that algo in production once it passes the test step, and then once it's in production for any new input x, it is able to predict the output y. So this algorithm, which is trained on historical data, is able to do predictive analytics by this mechanism. In effect, this is what we are doing in most of machine learning. So whatever we discussed so far, in effect, at the base, this is what is happening. So some common AI products we see, we are exposed to lots of interesting AI products nowadays. For example, Apple in our iPhones, Microsoft Cortana in Windows, which is again a chatbot. You can talk to it. Google Assistant in your Google phone, or Amazon last year in the US. It looks like a speaker, which we a chat enabled by Amazon Alexa AI there, which is trained on human speech. And we also have so you see now AI programs uh, somebody let me just get any comment here. Yeah, I'll just take some. So what has happened is that okay, let me just check. Somebody responded. Yes, if you can slide station of AI slide. Can you hear me now? Okay, let me reconnect my audio one sec. Okay, can you hear me now? Okay, great. So let's keep going. So I am the slide which deals with democratization of AI and ML. So what has happened is, you had to do low-level programming before if you are an AI developer, machine learning developer in Python or R or one of the earlier languages. Now Google, Amazon, IBM, OpenAI, these groups or companies have launched, high-level APIs. For example, Google TensorFlow, Apache open source from Apache Spark platform, IBM Watson, Amazon AI, MXNet, and there are several others. So what has happened now, they have launched high-level API for which are basically wrappers for many of these machine learning algorithms. So it's much easier for developers now to develop machine learning programs as opposed to before. But it's still a hard thing because these APIs make it easy, but you still have to understand the algorithm, the mathematical logic, the variety of combinations of algorithms. Okay. Okay, let me come back to my slide here. Okay, what are the some of the hottest AI technologies we see going forward? So we already spoke about natural language generation, NLP. We spoke about speech recognition, as in chatbots and Echo and Google Assistant kind of devices. We have virtual agents, from Alexa, IBM Cortana, and so on. We have different machine learning platforms from Amazon, Google, TensorFlow, IBM Watson, S2O.ai, and so on. We have AI optimized hardware from likes of IBM, Google, Intel, and so on, NVIDIA as well. And we have decision management systems which are using AI now from companies like Informatica, Pegasystems. We have deep learning platforms from MathWorks, IBM, and Google. Biometrics, which can be enabled with AI. And robotic process automation, often used in call center BPO environment. So you can argue whether it's AI or not, or is it classic automation, or is it really using AI? And then text analytics and NLP, for companies like Basis, Expert, and pretty much the entire chatbot ecosystem is using NLP. So how to really develop a defensible business around AI? You see, so if I am already in AI or I am trying to get in AI, what really matters? Okay, that is a question we want to answer. So is it those secret algorithms? Or is it the people you hire? So what happens with algorithms? You see, most of the top companies, they are actually publishing their algorithms, you know, or on their, on different research websites. The most popular research sites for machine learning white papers is called ARXIV. So you can write them down. ARXIV is the site where you find most of the research papers. So most of these algos eventually come out. Either the companies publish them directly, or somebody else will reverse engineer and find the algorithm. So how do you create a defensible AI business in that case? So it's basically about talent and data. So Sundar Pichai, CEO of Google, has said there are less than 10,000 good data scientists in the world today, whereas we probably need hundreds of thousands or millions already. So access to developing a data scientist, employee workforce or community, and also having access to data. So one of the first things businesses need to do when they want to get an AI is make sure they are collecting lots of data from all their business processes, because this data sooner or later will be enabling their AI, projects. So this is the two things which businesses need to focus on if they want to develop a long-term defensible AI business. Okay. So a lot of people have asked us, how can I develop a career in machine learning or data science? So there's a steep learning curve, agreed. So, AI and machine learning is not easy to learn because of the mathematical algorithms and the wide variety of them. And plus you have to then map it to the programming stack. So not only you have to learn the algorithms, you have to then map it to programming stack in Python or TensorFlow or R or whatever it may be. What are the kind of skills we need in a data scientist? We need programming skills, of course, statistical skills, machine learning, algorithms, data visualization, and communication. So, a true data scientist, given a question and a bunch of data, should be able to use some of the tools and develop an algorithm and develop a solution for that problem statement. So you can see this site on Forbes, what are the most important skills in machine learning. Okay, so this is a very interesting slide. So those of you who are trying to become, machine learning developers or data scientists, so there are two major steps. So one is the core machine learning. So this is the learning track for core machine learning. Okay. And you can see some of the resources which are listed here. We need to start with intro to AI and ML. We have to revise some of our high school maths, linear algebra, vectors, matrices, some basic calculus. And for developers, we want to definitely do Python or R or one of the other language. Then we go to statistics, which is optional to do traditional statistics or data mining aggregate algorithms. Then we have to learn about supervised and supervised, the various kinds of learning, decision trees, regression, classification, and finally on to neural networks. From the left, you can see lots of resources, online portals, as well as books, where you can find resources to learn machine learning. So this is the core machine learning program. You typically needs at least 6 months to get a good handle on it. Lots of theory and lots of practice with hands-on exercises, particularly if you're a developer. So what about deep learning? So deep learning is more complex. So it sort of doubles our agenda here. So you can see after core machine learning, I go on to more advanced topics like dimensionality reduction or convolutional neural networks, recurrent neural networks, NLP reinforcement. So deep learning sort of doubles up what I have to learn, and this typically requires 1 year of consistent training and learning through multiple sources. And so this presentation today webinar is being recorded. It will be available on our YouTube channel. So you will have access to these slides later on once on our YouTube channel, and you can use these learning tracks to develop a learning plan for yourself if you're trying to come into data science or machine learning. Okay. So finally, we have this Turing test. So Alan Turing was the famous scientist during World War II, and he developed, he helped the Allies army to beat the Nazis. He developed a computer. So the concept of Turing test is that can you develop a robot which acts like human, or can you distinguish whether this robot is human-like? There is a famous movie around this concept called Ex Machina. So if you have not already seen it, I recommend you check it out. And this movie has this female robot which interacts with a IT engineer, and then you can see. So the founder of that company is trying to do Turing test with that engineer and see if that engineer thinks of this female robot as a real human person. So check out this movie; it's very interesting. It's around Turing test. So we'll be doing lots of these webinars going forward. Our next webinar will be on types of machine learning. We'll be discussing supervised and unsupervised learning, as well as some of the algos which fall in these categories. We'll also be demonstrating some Python applications which we'll be running and demonstrating on this webinar. So the next webinar is actually scheduled this Tuesday, the coming Tuesday, I believe is 12th of December at the same time, and I invite you to attend that as well. So that's about it for today. Now let me just open it up for questions. I'll check what questions which have already come in. So I'm just reviewing the questions. So if you have any questions, this is the right time to ask them. So I want to start my career in data science. Please tell how to start. So my recommendation is, take some of those Coursera courses, Udacity courses. These are online learning. Ideal scenario to learn data science and machine learning is that ideally, and most ideal cases, I would recommend doing a PhD in machine learning from a top university in the US or India or wherever you are. So that is by far the best way. So the second best way would be a 2-year Master of Computer Science program with focus on machine learning, and again in a top university or institute in the US or whichever country you are in. But apart from that, if you can't go back to master's or PhD program, then there are courses on Coursera, Udacity, lots of good books. Some of those were listed on those learning track slides. You can check on Amazon.com. So I believe it takes about 1 year to develop a good intermediate level of machine learning. To develop good expertise, you need many years, but in 1 year you can become a pretty decent data scientist. And the next question was regarding reinforcement learning. What would be a reward for machine? See, the thing is, it's not like a physical reward. When we are developing a reinforcement learning program, there's a software, token or incentive within the program which is granted to the model. So if the model does desirable behavior in my program, within the code itself, I'll grant it a sort of a reward token. So it learns that if to get this reward, I have to repeat this kind of desirable behavior. It's a sort of a reward within the program itself, a reward token, if you will. Okay. And there were some audio issues. Sorry about that. I'm checking the question list here. Will you share this deck? So we'll not be sharing this deck, but this session was recorded today. It will be available on our YouTube channel, and you can always access it from there. Okay. Can I get this slide? So yeah, you will be able to see this entire presentation on our YouTube channel. It will be available after some point. We'll send you the link once it's available on our YouTube channel. Can a non-math person go into AI ML? So good question. So you see, is AI and machine learning is not only about math. So let's say you are an AI company, an AI startup, or a large MNC in this segment, or a large technology company. So we need all kinds of people in an AI company. We still need sales and marketing folks who understand AI and who can sell AI, can market AI, can develop content around AI. We still need program management folks who can run projects in this segment, right? And so we not only we need technical data scientists, we also need functional architects who can design the algos. So we need developers also. We need functional architects also. So both functional architects and developers would have to understand the mathematical algorithm to a great extent, but the sales, marketing, product, program management guys don't have to. Okay, so it's not like you have to have maths knowledge if you want to get in AI. What is the scope for testers in ML? Yes, I mean, the whole thing, it has to still go through the classic software lifecycle process, right? Once we deploy AI programs, it has to be tested before we can turn them on in production. So we still have to do unit and regression testing, and the testers have to become much more sophisticated. So they have to learn about AI and machine learning, and then they have to know how to test the accuracy of the AI programs developed by the dev team. Okay. I'm a Splunk professional engineer. And I do multiple stuff related to operational intelligence. I guess that's not a question. How to avoid bias which comes during the training of data? So bias is yes. So we didn't discuss bias today. Bias is the concept where the data is biased around the average of that data. Okay. So we have to avoid bias. We need lots of data. We have to increase the variance. So if you have lots of data, we can reduce the bias in our machine learning model. Okay. So bias and variance are opposite concept. So variance means a more larger data set. So by increasing the data set or by trying different more sophisticated algorithms, we can reduce the bias in model training. So is it good to be a data scientist now? Oh yes. So I would say for we technical folks, it's time to rejoice. You see, yesterday I read an article. There's a conference called NIPS conference going on in California. It is the most prestigious conference in the world, and in companies like Intel, IBM, Google, Amazon, they're just throwing money at these people. So if you can learn data science and machine learning, you can assume we are hot property. And the minimum salary is around $300,000 in Silicon Valley. And for top data scientists who have many years of expertise from university or otherwise, they are paying them millions of dollars annual packages. So yes, we the technical people, we can rejoice right now if you can get into these kind of areas, deep tech areas. How to identify the right application of AI for business use cases. So you see, this is something which, so we have to first of all train ourselves in AI and its possibilities, right? So if I am a business, and how to identify uses of AI in my company or in my business. One sec, let me just remove the Norton alert. This is bothering me. Okay, put it on silent mode. Okay, sorry about that. So, how to identify AI use cases in my company or business. The way to do that would be, first we have to understand what is AI. What are the things the capabilities it enables? For example, classification, regression, text, image, speech, and so on. So, just learning through it, we'll find some use cases and doing some focused workshops. And we in CellStrat can certainly assist with that process. That's what we do as part of our consulting activity. Okay, next question is, an engineer who is not into core coding but into debugging skills can get opportunities in this domain? Certainly. So you see, so only one class of AI people need to have programming skills, the programmers. But we still need functional architects, functional data scientists, right? We still need sales and marketing folks. We still need product folks. We still need program management folks. So we need broad level of people in AI domains or AI projects. It's not like I hope you can hear me. If you can hear me, please raise your hand. Can you hear me? Okay, great. So let's keep going. So the question was for non-programmers, or non-technical people, how will this work? So, we still need functional architects who understand the mathematical algorithms. We still need program management, product management, sales and marketing folks. So there's a broad kind of needs in the AI domain, not just programmers. Yeah, we'll be sharing YouTube channel link later. Okay, I don't exactly understand the concept of rewarding the AI algorithm. So basically, it's a software program. When you write a reinforcement learning program, within the software program, you have an agent, you have an object called an agent of the model which you are training to do certain actions. And when it does certain actions, and when you find it did that action, so there's an if-else loop. So if it did the action you wanted it to do, you will give it a reward. So reward will be within the program itself. There is no other like physical reward per se. It is a programming token. So the agent in the software is all a software program at the end of the day. The software program starts understanding, the model starts understanding the model object that if I did this, I will be given this reward token. And hence it is likely to repeat that. So because this is what is happening in AI. The model is being trained again and again and again with newer batches of data, or in the reinforcement learning case with after receiving reward or penalty tokens. Is it possible to intern with you? I mean, certainly, just reach out to us. So we have a sort of a AI lab program where we want to encourage AI startups. We want to research projects with them and product development with them, and see if we can assist with the product development activity. Okay, for students, interns, as well as other folks who are interested in working with us. Would you be able to give us 3 courses online and offline both, as I like more of instructor-based courses? Yes, so if you are based in Bengaluru or Delhi, we run offline courses as well. And for online, we'll be launching online courses in near future, where you can actually go through a training program through online webinars wherever you are in the world, and these will be certificate programs, and in many cases there are hands-on exercises involved in Python and TensorFlow. Okay, how much time do we need to become a data scientist? I'm ready to spend 2 to 3 hours per day. Okay, so yes, so I mean, that sounds about right. If you are, I assume you are a working professional, then just 2 to 3 hours per day should be enough. But as I said, ideally you should plan for 6 months to 1 year worth of learning if you don't have any prior background in this space. You can start with courses on Coursera, some of the leading books on Amazon and so on. That's how you get started. So you have to do a lot of courses and a lot of reading. And if you are a developer, I highly recommend you set up a Python TensorFlow environment. It runs on your regular desktop or laptop as well, or you can have a cloud service on Amazon for yourself, or your wherever you can get servers. And so you can run some programming tutorials that will really help develop confidence, for particularly those who are developers. But for those who are non-developers, can still learn it. They can learn the business applications around it and also the algorithms around it. Any good courses you can name there? Yes. So on Stanford University, Professor Andrew Nug has one of the most popular machine learning course. So Andrew NG is one of the most popular instructors on Coursera. He is in fact a professor at Stanford, and he's also the founder of Coursera. So you can check out Andrew NG course on Coursera. And there are a lot of Stanford, MIT, Carnegie Mellon programs on Coursera, and also you can check out a website called Udacity or Udemy. So there are a lot of online courses which are available at very low price as well. So I am a Splunk professional engineer working in a Splunk company. See, unfortunately, I don't know what is Splunk, so I'm unable to answer questions about Splunk. But yes, data science is a very good career to be in. I do not think there is any area left which will not be impacted by AI. So whichever company you are in, whatever you do, sooner or later, you are going to be impacted by AI and machine learning. So strongly recommended that we at least get a preliminary knowledge of AI. How much do we charge? So once we launch, online courses, we'll figure out the charge, but it will be very nominal. We understand online teaching is probably slightly less effective than offline. So if you are in Bengaluru or Delhi or can come here, we offer offline courses here in classroom format, but the online courses which we are going to launch will be cheaper, but they will be accessible by global audience. Yes, so there are a lot of institutes charging very high, fees for these online courses. So just be wary of them, validate them, check with friends who have done those courses before signing up. For a salesperson perspective, what are the keywords to pitch prospects? So you see, it's about AI, machine learning, and deep learning. And some of the problems we can solve are, natural language processing, speech chatbots, text analytics, image detection, and so on. For example, in a factory, if you are a manufacturing company or you have a manufacturing client, you can sort products automatically using computer vision, deep learning technology, rather than using human sorting, and so on. So there are a lot of variety of applications for salespersons to basically pitch to their clients. So can you please repeat variance and bias again? So in the next session on Tuesday, which we'll do, we'll be discussing what is variance and bias. So variance is the variety of training data which we get. Okay, that's what is variance essentially. And bias is that we are working with a bias that most of the training data has to fit this particular output value. So those two are, contradictory slightly. Variance is trying to, train the model on variety of data, whereas bias is trying to say, oh, most of the data has to be around this average. So those are contradictory concepts. And once we do the next session, we'll explain in detail what is exactly variance and bias, technically speaking. Okay. Where is AI applied most in businesses in India? Okay, so in India we see, chatbots, bots a lot, but bots is sort of the first level AI. It's not very advanced stuff. And Amazon has Amazon Alexa layer. You can train its Alexa chatbot to work on Amazon Echo devices. And so, they are enabling an app store for Amazon Alexa applications. And in India, AI is still relatively new. We find that, manufacturing companies, retail companies, for example, e-commerce recommendation engines. If you go use buy product from Flipkart, eBay, or Amazon, they are using AI algorithms to personalize the product offerings which you see. So this is called collaborative filtering. It's one of the AI algorithms or machine learning algorithms which is used by e-commerce companies. So I would say in India, e-commerce applications are one of the first users of AI. We also see it in manufacturing and a few other cases. Now, okay, I forgot all my maths from high school, like algorithm and algebra. So you see, if you are trying to become a technical data scientist, yes, you have to revise some of the linear algebra and basic calculus from your high school days. You see, we can't avoid that. Now, if you are in marketing team or program management team, sales team, business development team, you don't really have to. So only the technical data scientist, either the functional data scientist or the programming data scientist, has to revise the the algorithms and algebra, and not the other folks in an AI environment. How does unsupervised learning algorithm understand the bias in the data set? So they seem to be unrelated concept to me. Unsupervised learning mostly is used for clustering. So the concept of bias doesn't come there, but I suggest you attend our next seminar or next webinar this Tuesday. So we'll be discussing, what is unsupervised learning and what is bias. Bias and variance are mostly used in supervised learning use cases, okay? Is remote internship possible? Yes, so reach out to us. Let's see what we can do, okay? Where can I get data sources for trying my hands on POC? So there are a lot of online data sets available. If you are trying to do machine learning development, there is the famous MNIST dataset. There is IRIS dataset. There are lots of online dataset. If you were to just Google machine learning datasets, you'll find lots of them online. Lots of online tutorials are available on GitHub, which is the programming repository used by most of the developers in the world. So you'll find datasets embedded with the programs and the projects. Next question is, I observed that there is technical statistical information available, but I am struggling to plan my learning journey. What should be the steps? Okay, so I didn't really understand the question. I mean, once I am done basic stats in Python, what is the next step? So you have to learn Python. If you are trying to be a developer in AI world or machine learning world, you have to learn Python, which is the most popular language. R also is used, R. But Python, scikit-learn, and TensorFlow is the most popular programming stack. Okay. Okay, just one final question before we close this session. I'm having 16 years experience in testing. Yes, so you can still become a functional data scientist. You can still become, learn the algorithms even as a testing engineer, and you don't have to be programming for that. Okay, so I think that's about it for today. We are out of time now. If you have questions, kindly reach out to us. You can take them offline. And in fact, let me remove these pop-ups. Sorry. So that's it for the day. Thanks for attending, folks, and look forward to our next session on Tuesday. All right. Thank you.